It's in every respect teamwork with a large cast of extremely indulgent co-authors who've allowed me over the years to just keep on thinking of different ways to merge different stuff at every turn, impeding my progress on the things that I had promised them, but eventually coming up with something that I think is hopefully useful to the larger community. Second thing to note is that the 1200 on the front slide is not actually a typo. We'll actually start in roughly 1215 with an example of just how wide the range of sources are that we can now subject to the kind of linking and matching algorithms that I'll be talking a little bit about and that Martha will be talking about in even greater detail. So for those of you who don't remember your canon law history, in 1215, the Lateran Council, among many other things, decided that you could get married to your fourth cousin, but not to your third cousin, and anything further out than fourth they didn't care about. But they also put into place a very elaborate procedure that allowed people to seek dispensations from this aspect of canon law. And those dispensations began a long trail of paperwork that starts with an interview with the local parish priest, goes up to the archdiocese, and then from there all the way on to the Vatican, where a decision is made, paperwork flows in the opposite direction, and eventually, after a period of time, sometimes a matter of several years, you'd find out whether you could marry your second or third or even first cousin. The idea here was that the exception was to be granted in extraordinary circumstances, and among the circumstances that they thought extraordinary enough to allow these violations of canon law was situations in which it was necessary to avoid further subdivision of the family land. So what's nice about this is that it gives us an important piece of information about population pressure on the land. But from the purposes of this lecture, what's nice about it is that it's got a long paper trail, and that the church entertains a lot of these requests, hundreds of thousands of them, over the course of the 8 centuries, from 1200 down to 2000. And the Catholic Church, like my parents, never throws anything out. So that means that this stuff is in church archives all over Catholic Europe, even today, and it's very easy to access. Here's an example from the Diocese of Girona, which is just north of Barcelona on the Spanish Mediterranean coast. And what you can see here is one page from the extensive dossier that's generated for each one of these cases. The first thing that shows up is a family lineage that describes in detail the exact names and birth dates and circumstances of the people whose relatedness is the impediment to this marriage taking place. For every one of the 300,000 or so documents of this sort that we've uncovered, you get this kind of detailed lineage. This is interesting in and of itself because it tells us where population pressure was seemingly impinging on marital decisions. And these things are all over the place and span a long span of time. But the value of this resource, like many of the other resources that we'll talk about over the course of the next 90 minutes or so, increases dramatically when it can be combined with other sources, in particular, in this case, parish birth, marriage, and death records. Now, with the combination of the dispensation records and these local parish records, from which we can infer population growth, we can see how much population pressure was necessary to result in these dispensation requests. And in a rough way, create a proxy, once we have these other records, for population pressure across the rest of Europe for a long span of time, during which we have neither census records nor good information on arable land. The basic idea that I've described here, combining population records with administrative sources, therefore is not new. It's something that we could do going back well into history and with these extraordinarily rich sources. What's really new today, and what I think prompts the interest in what Martha and I will be talking about, is the fact that the scale of those sources that we can now link and the criteria by which they've become matchable have now evolved to the point where this is actually feasible to do on a very large scale. So in the case of the dispensation records, we know the name of the bride and groom and their parents and their marriage year and their parish. This gets us into the birth records and their death records with just a little more effort. But this is, again, not completely novel. This is the sort of thing that people have been doing with US sources, like tax records and censuses, since the 1950s and the 1960s. James Malin, Merle Curdy, Alan Bogue, Stephen Thernstrom. More recently, beginning in the 1980s, Rick Steckel and Jeremy Atack. What changes between this first group in the 60s and more recently the 80s and beyond is a shift from retail to wholesale linkage. Retail being the kind of work that Stephen Thernstrom did in Poverty and Progress, where he took the entire population of Newburyport, Massachusetts in 1850 and looked for the same people in 1860 and 1870 and 1880, and painstakingly, by eye, went through the entire manuscript census schedules for Newburyport to do those linkages. Now, with the availability of data that's already transcribed, that's already indexed, and that contains all of the relevant identifying information, these sorts of linkages can be done wholesale, which, as we'll see, is both a blessing and a curse. There's a bit of a challenge in doing this successfully in ways that will ultimately provide convincing results from the data that's produced in this manner. So there's something of what I'll call a renaissance in linking, especially with historical records that we've been able to see over the last several years. Some unique historical circumstances combine to make this kind of linkage much easier. And just in the very recent past have these circumstances become so important. One, obviously, computer processing power and storage costs. I could store the entire 1790 through 1940 US censuses on a single thumb drive. Every single individual in the country on a single thumb drive with all their identifying information, everything they reported in the census. There's also now something that graduate students take advantage of routinely, which I didn't have access to when I was doing this as a graduate student, which is cheap offshore transcription services, and for records that are, even some that are transcribed, that are written by hand rather than typed, but better for typed records, better OCR technology. Finally, there's been a real change in the degree of intergovernmental cooperation. For example, the Census Bureau and Social Security now routinely exchange data in ways that make it possible to attach information from one source to another in ways that dramatically enhance the utility of either source. So, for example, Social Security records contain detailed date and place of birth, and attaching those to census records, which generally only record year of birth and state of birth, makes possible a whole lot of exercises looking at circumstances at a specific time and a very specific place in the life cycle. I like to think that this renaissance in linking is comparable to what John Abad will talk about in a few weeks, which is what began with the LEHD project at the Center for Economic Studies in the Census Bureau in the 1990s, which was a linkage project of just this sort, just this scale, involving cooperation across a variety of government agencies, and it produced an absolutely invaluable resource for studying things like flows into and out of employment and the life and death cycle of individual firms. The challenge that we face, that I'll try and say a little bit more about, is combining and making use of all these sources that have now become available. And that in itself is no trivial concern. Fundamental to the concern that people will have to have in looking at the research that emerges from this is the reliability of the links that are made, a point to which I'll return in a few minutes. Let me just give you one example of the kind of information that becomes available through this interagency cooperation. This is an SS5 card, which is what everyone fills out when they enter the Social Security system. It's the information that they use to identify you when you come to start collecting your Social Security payments at age 65 or 67 or whenever. It has information that pretty much only you should easily know. For example, this person, one Eldred Gregory Peck in San Diego, California, born April, I think that's the 15th actually, of 1916 in San Diego. His parents are Gregory Pearl Peck and Bernice May Ayers. We know that he's living in San Diego around the time that he applies, and he's doing so in 1937. So he's already 22 years old when he applies to enter the Social Security system. This obviously is the movie actor Gregory Peck, but basically everybody has one of these cards somewhere in the system. And when Social Security allows the Census Bureau to take this information and attach it to census records, it produces something quite extraordinary. I'll give you some examples of historical linkage and then talk a little bit more about modern linkage, and then get on to the problems and challenges. So among the kinds of things that we've been able to do in just the last couple of years that were virtually impossible to do as recently as 10 years ago, linking multiple generations across US population censuses. So the entirety of the 1790 through 1940 censuses, except for the lost 1890, are now publicly available. Beginning in 1850, the census begins to ask questions in a way that makes it possible to identify every individual within a household. It asks their full name, their age, their detailed place of birth at the state level. And that makes it possible to follow those individuals over time by linking them to subsequent censuses. In order to adequately do this and to understand how good a job we've done, you need to clearly account for some of the obvious problems. Underenumeration, the census never gets everybody. Mortality, if you observe someone in 1850, it's possible that they will not still be alive as of 1880. And then there are myriad mistakes and variations over time in things like the spelling of the name and in the reporting of age and birthplace. All of these are impediments to successfully locating the same individual at different points in time. Nonetheless, in my own work, we've gotten linkage rates about as high as 35%. That's a point to which I'll return in a little bit. Here's an example of linkage from 1850 to 1880 to 1910. This is Thomas Goodrich, who's located in Kalamazoo County, Michigan. He's here as the head of the household. He's got a couple of kids, Charles, Maria, and Charles. Actually, one of these is a typo. It's not supposed to be, the other one's not supposed to be Charles. In any case, in the next generation in Montcalm County, Michigan, you can observe the child who's listed as the first Charles there. This is an individual who's got exactly the right age, given what his age was reported to be in 1850. He's got exactly the right place of birth for himself and for both parents. And there is only one Charles H. Goodrich, even allowing for variations in spelling, variations in the middle initial, who would fit into this family based on the entirety of the 1880 census of population. We can then take Charles's son Thomas and locate Thomas in the 1910 census. He's now living in Seattle, and he's got a son named Francis. And Francis, I ran out of space to show more of the slides, but subsequently ends up in Detroit, all the way back in Michigan after the family had moved out to Seattle. The ability to link 4 generations like this and to do this for hundreds of thousands of families is a complete novelty and something we've only been able to do within the last 5 years with the release of the full count files from Ancestry from 1850 to 1940. Just to show you that I actually had to, at one point, look at extremely illegible census manuscripts. This is what the original pages would have looked like if I had had to transcribe them for this exercise. That's Thomas Goodrich, that's Charles down there at the head of the household in 1880, and this is Thomas as the head of the household in 1910. What can we do with this? Once we've got households in which we link fathers to sons, grandfathers to sons, great-grandfathers all the way down to their great-grandsons. What we can do with that information, at least at first, is to look at an enduring question in American social history, which is how much mobility has there been across generations. And for this exercise, what we've done is simply rank occupations by their educational content and tried to get a sense of, by birth cohort, what mobility looks like over time. This is showing the correlation across generations, so increasing correlation implies decreasing mobility. And we start over here with the 1830s birth cohorts. Mobility looks relatively stable. Mobility seems to decrease because the correlation increases for cohorts born after 1860. It then levels off for the cohorts born from 1890 down through 1910. And then from bits and pieces of information that we have in a whole set of other surveys, it looks as though the correlation is somewhat higher on average in the 20th century, the second part of it, than it was previously. This stuff over here at the right-hand side is not new. All these data sets were available before we did the linkage of individuals from household to household, but all this stuff from 1830 down through the 1910 birth cohort is completely new. We could also take a look at some of those very early life circumstances because we know people's detailed place of birth. So what we've done here is to look at individuals who are measured in terms of their intelligence at the time they enter the US Army in the Second World War. They take something called the Army General Classification Test, which is basically an IQ screen. Individuals who scored highest on this test were most often shunted off into the Army Air Corps because they required and consistently succeeded at getting the highest scorers on the AGCT, making the case to the Joint Chiefs of Staff that this was an enterprise that required people with an unusual degree of intelligence. So on the left-hand axis, what you have is the probability that an individual was assigned to the Army Air Corps, basically a proxy for whether they scored in the top quarter on the AGCT. And then at the lower axis, what you see is the pH of the water supply in the place where these individuals lived as children. And we get this by linking them from the World War II enlistment records back to where they resided in 1930. There's a well-known relationship in water chemistry between pH and something called plumosolvency, which is how much lead leaches into the water for a given amount of lead piping. And it's a conveniently non-monotonic relationship. It basically looks as the mirror image of this. Plumosolvency is minimized at a pH of between 7 and 7.5. So if you look at some cognitively sensitive outcome, as in this case, whether you scored high enough on the AGCT to get into the Army Air Corps, you would anticipate, if lead is a problem, that it should be a greater problem at places that are either side of the minimum point of plumosolvency. And that's exactly what you see. The scores are dramatically lower at points either side of roughly 7 in this calculation. This is for cities that had lead pipe. If we look at cities that don't have lead pipe, there's no relationship between pH and the probability of scoring high on the Army General Classification Test. So this seems pretty convincing, at least to me, that what we're observing when we're looking at pH is a good proxy combined with the presence of lead piping for waterborne lead exposure early in life. And again, the sort of thing that we could not have done, not just easily, but not at all, just a few years ago. One more. This is some work with Hoyt Blakely. So this looks at the effect after 18 years of winning a plot in the 1832 Georgia land lottery. The state of Georgia auctioned off part of its land, but most of it distributed through a series of land lotteries between 1805 and 1832. We took the winners of the 1832 land lottery, which is basically the northwest corner of the state, which includes modern-day Atlanta, and we followed them over the next 18 years to see how they're doing as of 1850. And what you can see is that for individuals who won a plot of land but were at the lower tail of the distribution, the effect of winning is virtually nil. It's not until you get to above the median that it appears winning has any substantial effect on your observed 1850 wealth. And it's extremely large, that effect, once you get to the very upper tails. This suggests that in this case, if the treatment is receipt of a plot of land, which in this case is worth roughly median wealth in the state of Georgia at this time, if that's the treatment, then there's a really heterogeneous treatment effect here, that the effect is much larger for people who already were doing quite well. And that has some implications if you want to think about just making people wealthier by transferring money directly into their bank accounts. More examples, a couple are even non-laborish. The kinds of things that you can now do with these linked historical records. You could identify financial actors, for example, owners, directors, shareholders of firms, and observe what they look like over time, how their characteristics differ, how people involved with different enterprises differ. You can look at something that I think Jeremy mentioned he was going to be working on years ago, which was the persistence of manufacturing firms, using the manufacturing schedules of the Census of population. One of the things that we're actually possibly going to be working on in the very near future is radioactive fallout exposure in childhood and adult outcomes, including IQ. And this too is something that's only possible once you know exactly where people are growing up, down to the level of the city or census-defined place. Early life lead exposure and late onset Alzheimer's disease is an issue that's been of increasing interest in the community of psychiatric epidemiologists, but there's been absolutely no data to do this at scale and get a sense of just how strong these relationships might be, because there's obviously no data set currently available that follows someone backwards from a late onset Alzheimer's diagnosis to their early life exposure to waterborne lead. The kind of data that we have now allow us to do just that. A project that involves Claudia and Claudia Olivetti is looking at the preschool experience of individuals between 1943 and 1946, when the federal government was funding large numbers of preschools in order to encourage women to enter factory employment when conscription was at its peak in 1943. We can link those individuals, or at least the people who were in the towns that were exposed to this kind of preschool experience, to their adult outcomes from 2000 to 2015, and even to intermediate outcomes as early as 1973. Rick has been working over the last several years on slavery and the intergenerational transmission of hypertension. This too would have been impossible to do as recently as 5 or 10 years ago. Finally, there's also interesting work being done on the impact of environmental disasters on outcomes like migration. So Rick Hornbeck has done some work on the Dust Bowl, and he's got other work in the pipeline that looks at similar issues. The Census Bureau has gotten into this act itself. That is, it has become increasingly interested in allowing individual researchers to come in and take advantage of sources that they have prepared for linkage in ways that would allow us to do things with modern census data that until now we've only been able to do with historical publicly available census data, data that's already released because of the 72-year rule that prevents the manuscripts from being released until 72 years after the census is taken. So the Census Bureau has undertaken something called the American Longitudinal Infrastructure for Research on Aging project that makes it possible to link individuals across currently closed census records, to do so within a secure census research data center environment, and to do many of the same kinds of things that I've described us now being able to do with historical sources. The idea is basically to use the information that Census has from Social Security and other places like the IRS that makes it possible to assign a unique 9-digit identifier called a PIC to each individual, and that number persists with that individual across multiple data sources. So PICs internally are used to facilitate unduplication and to allow for record linkage of this sort. Once it's done, once an individual is picked in one of these sources, they can be very easily linked across a variety of sources, and there are some examples listed here. So for the Census Bureau, anything that's been run through their PVS system has a unique identifier, consistent across sources. Clearly, we've already got 2000 and 2010. Seth Sanders and I are working on completing the picking of the 1940 census that makes it relatively straightforward to link individuals who were children in 1940 to their outcomes in the 2000 and 2010 censuses. We're working on 1950 to 1990. Ask me again in about 6 months. The current population surveys from 1973, 79, and 81 through 2015 are all picked and therefore available for linkages of these sorts. The Survey of Income and Program Participation, the redesign of the SIP, is also picked. The original NLS cohorts, Social Security earnings records, far too many things for me to actually list here. There's a treasure trove of information that's there, and there's an increasing willingness on the part of the Census Bureau to allow people to come in and exploit those resources. Now, how about the matching? How about how comfortable we should be with the reliability of these matches? So Orwell always said that tired metaphors, actually any metaphor that's been used before is probably a bad one. But sometimes I think the tired metaphor is just the right one. And here we'll take one from Bob Fogel's essay on circumstantial evidence in the Two Roads book with Jeffrey Elton. He describes the chains of inference that we, as not just economic historians, but anybody who works with quantitative evidence, have to keep in mind, and the links that comprise each of those chains of inference. The weakest link in most of what contains a linkage component is clearly the quality of the links themselves. And this is especially problematic with very diverse sources, because those sources have been created for different purposes, and they don't have in mind how easy it would be to link those people to other sources of information. They have their own institutional imperatives that lie behind the collection of the information in the first place. Weak links are a problem, but not all weak links are created equal. Some of them have a different impact on the confidence of our inference that we draw from work with linked data than do others. For example, when linkage generates right-hand side variables. Think about a simple OLS regression. A weak link is going to generate noise, which is often okay. It's just going to reduce our ability to precisely identify a particular effect. Martha has some important counterexamples dealing with intergenerational mobility, which she'll talk about. When the linkage itself or its absence is the outcome, that's when we have to be particularly cautious. Because if you're trying to infer something like migration or mortality purely on the basis of an individual not being successfully linked, you really have to be careful at taking account of all the things that could possibly go wrong in the process of that linkage. And that's the only way to make a convincing case in that situation. So what have we learned? One is that there's a clear trade-off between scale and precision in linkage. It's that wholesale versus retail contrast that I described earlier. That trade-off is inevitable. What we need to do, and again, Martha will talk more about this, is to assess the linkage rate, how many individuals are successfully linked, the reliability of the links, in particular how many false positives we get, and also how much bias there is. How different are the characteristics of the individuals that we're successfully able to link versus those that we can't. So she'll say a little bit more about that in a bit. Keep in mind that there is no one point on this trade-off between scale and precision that's ideal for every single circumstance. You can't just unilaterally say that a particular degree of bias is bad, or that a particular degree of false positives is crippling to a particular analysis. You need to keep in mind what the context is and what the magnitude of the effect is that you're trying to assess. Keep in mind also that even modern link data are imperfect in ways that could be fatal in some settings. As part of doing the census work, I had to get a DUNS number from Dun & Bradstreet. So I went on the Dun & Bradstreet website and I put in all my information, my social security number, and all the information that they wanted. And like you do when you forget a password, it asks for answers to a set of questions that you should only have the information to answer. What was the model of your first car? What town did you meet your current spouse in? What was the name of your first pet? I answered all three questions, and I got all three of them wrong. But then I went back, and I asked them to give me the questions again, and I ran through the procedure again, and I realized that for each one of the questions I answered wrong, there was an answer that pertained to my father. His first model of a car was an Edsel. Mine was a Galaxy 500. He met his spouse in the town where I was born, Edgewater, New Jersey. I met mine in Chicago. And his first pet was a black dog named Scotty, a Scottish Terrier. And mine was a cat named Blackie. But nonetheless, all of the answers pertained to him. And it was clear what had happened. Dun & Bradstreet thinks that I'm my father, which in itself is fine because he's got a higher credit rating than I do. And it means that if I want to refinance again, I'll get a better deal than I would otherwise. But it means I'm in for a world of hurt when my father passes, because Dun & Bradstreet will think that I'm dead. And that will be a process, to change that would be a very complicated process. And the people at Dun & Bradstreet just said, you know, it's not really worth it right now. We'll deal with this when your father is gone. But for now, just leave it. And I got my DUNS number. But Dun & Bradstreet is supposed to know these things. It's supposed to use the same very best sources and techniques that are available to anyone doing modern record linkage, and they still get me and my father wrong. We don't have the same middle initial. Our birth dates are off by 35 years, and I haven't lived in Edgewater, New Jersey since the age of 18. So they're way, way off in ways that will be crippling for me if I have to deal with this in a couple of years. So the bottom line here is even modern data are imperfect in ways that can be a problem. The best approach to all of these challenges, I think, is recognizing the imperfection of linkage and its possible impact on the outcomes that we're trying to measure. To be as upfront and transparent about this possibility as possible, and to do everything to try and assess how large it is and whether it's likely to overturn our findings, whether we have actually generated data that produces results that are incorrect solely because of the way the linkage has proceeded. I'll talk about something called synthetic truth in 2 more slides, and Martha will talk in more detail about this as well. That was lessons learned. Let me talk about some lessons that we haven't learned, things that I don't want you to take away from this presentation. One is, again, apologies to Orwell for the tired metaphor, but don't toss out the baby with the bathwater here. That is, don't dismiss work involving record linkage solely because there are problems associated with it. Get a handle on what those problems are and try to understand whether they really do bias the results in a fundamental way. What I've got here is a heavily redacted excerpt from a journal referee report, not on my work, but rejection of the article was recommended. B has a paper forthcoming in HM that compares false positive rates using different linkage methodologies. Human eyeballs on the data does best. The false positive rates for some of the mechanical linkage methods are best described as, quote, scary, which itself is in scare quotes. I'm pretty sure, you can correct me on this during the Q&A, but I'm pretty sure that no one has ever rejected a paper because of scary standard errors. It's not standard errors that we care about. It's the ratio of the coefficient beta to the standard error that we care about in itself. And even that needs to be viewed in light of whether the coefficient that we're interested in is of substantive significance rather than simply statistical significance, in the way that Deirdre has been urging us to look for going on 32 years now. How can we address these shortcomings? How can we convince readers and editors and referees that we've done a good enough job in the linkage that they should have faith in the conclusions that we reach based on the linked data? I'll talk about something called synthetic truth very briefly, and then we'll finish up. I'm not talking about alternative facts here. Instead, I'm thinking about a way of generating truth data for verifying links that's generated synthetically. It doesn't rely on individuals actually eyeballing the data or getting genealogists to do the work. The big problem in assessing linkage technologies is finding true matches against which to compare these algorithmically generated automatic matches. The option that I've hit upon, and it's not even close to being an original idea, people in the record linkage literature have been doing this for decades, is to pretty much roll your own truth deck. Again, that's a horribly mixed metaphor. This is something that any paper with linkage could easily incorporate in an appendix. And I don't want to just say could, I want to say should. That this is something that I'd actually urge prescriptively. So editors and referees, here I'm talking to you. It basically consists of taking an existing data set and screwing it up as the information would be screwed up if it was collected again from the same individuals X years later, which is fundamentally what we're doing when we're trying to link them over time. As an example, I've taken the 1850 US Census population and screwed it up to mimic the same individuals as if they were appearing in the 1880 US Census. How do we do it? Well, we think about what are the things that, based on our experience in doing record linkage, could possibly go wrong. Under enumeration, as we mentioned earlier, so drop some of the observations from the quasi-1850 data set, but leave them in 1880, or vice versa. Mortality, some people don't survive, drop them from 1880, leave them in 1850. Spelling variants for names, first, middle, and last, myriad ways that this can go wrong. Year, place of birth mistakes, again, a whole bunch of ways that can go wrong, but they can go wrong in predictable ways. What are plausible magnitudes for these? Well, we take advantage of the fact that David Hacker has estimates for underenumeration and for mortality based on the census in just this time period. And the city of St. Louis was actually enumerated twice in 1880. I think in part because St. Louis thought that their population had grown much more rapidly than it actually had. They thought they were going to be the real capital of the Midwest rather than Chicago, and they implored the Census Bureau to come back and recount them again. And they did so just a couple of months after the original 1880 enumeration. Because this was done at a time when we actually have street addresses for every individual in the census, it's quite straightforward to match individuals and households without actually matching on particular sets of characteristics. And you can see exactly how far off things are. How many people misreport their name, or how many people give a year of birth that's X years off from what they reported the very first time around. What I've done here is just given you a couple of quick examples of how that process of generating synthetic data and trying to match it between the original source and the synthetic one plays out. So I'll give you just two things to take away from this. If we just look at individuals who are age 5 to 15 in the original census in 1850 and allow no tolerance in their reported age, that is, we assume that everybody reports their age exactly correctly, and we allow no variation in the spelling of their name. We assume that everybody reports their name with exact correctness. What we wind up getting is 94% of the population linked. Not 100%, just 94%. And the reason it's not 100% is because of pure disambiguation error. Being unable to simply distinguish between two individuals who share the full set of characteristics exactly. Exact spelling of name, exact place of birth, exact year of birth. And those individuals you can't distinguish among. What to do with them is a question that I'm going to set to the side. But in this exercise, you don't get the entire population because of them. If we move on and instead allow a 3-year age discrepancy, we allow for some variation in the spelling of the names, first, middle, and last, and then we mess things up in the ways that I described. We screw up their birth year, consistent with what we know the screw-ups were in St. Louis. We do the same with their name, their birthplace, their parental birthplaces, and then mortality and underenumeration. If we do that, we get down to about 36, 37% linkage predicted. 36 or 7% is the fraction that we actually do link with this synthetic data. And that's pretty much close to the usual. That is the number that people usually are able to derive when they do this kind of linkage. So this suggests that this is one way of assessing how reliable record linkage is. The other thing to note here is that in terms of the fraction that are correct, that is the fraction where we've actually matched to the correct individual, it's 98.2%, which means that the rate of false positives in this data is only 1.8%, which is quite low. But I still haven't gone as far as I could. I haven't built in correlations across the types of error, and I haven't built in particular kinds of bias. But that's exactly the sort of thing that you can do, and do in a way that should ultimately satisfy readers and editors and referees with this kind of data that's designed to be appropriate for a particular matching context. Okay, let me finish up. In terms of conclusions, clearly there are linking exercises that are going to produce data that's more valuable than the sum of its parts, than any of the individual pieces of data. The process is fraught with challenges, but it can nonetheless generate invaluable insights that you'd not get from any other kind of data. We need more standards to assess linkage quality, and again, Martha will talk more about that. We, by whom I mean all these kinds of people, can help in this process of standardization by requiring basic analyses of linkage, reliability, and bias as part of any paper that's submitted that has a substantial linkage component. We need to do this now because the range of possibilities is only going to expand. So the time to address these concerns is not even now, it's yesterday. But this is definitely the time to be worrying about exactly these issues. Thank you.